Welcome to this discussion. We have this equation here for us to get the solution. The equation reads, the charge Qt on the plates of a capacitor satisfy the differential equation 2d2q dt squared plus 7 dq dt plus 3q equals sine t. Use method of undetermined coefficients to determine the general solution of the equation. The equation is on the whiteboard. Solution. Now, the first thing for us to do is to extract the auxiliary equation from the given equation. Now, the auxiliary equation there will be 2m squared plus 7m plus 3. Of course, we let it equal to 0. Then, as you can see, this auxiliary equation is just a quadratic equation where we need to get the value of m. So for us to factorize this equation, we'll take 2 times 3, that is 6. And then we ask ourselves, there are two numbers. When you add, you get 7. When you multiply, you get 6. Do we have such numbers? You add, you get 7. You multiply, you get 6. Okay, we can still use the quadratic formula to get the value of m. The quadratic formula is given by m equals to minus b plus or minus the square root of b squared minus 4ac over 2a. So that is the quadratic formula. Now, from this equation, a equals to, this is a equals to 2, and then b equals to 7, and then c, which is this one, equals to 3. So once we have these values, we insert in that formula to be able to get the value of a. Now we shall say that m equals to, now b is 7, so it will be minus 7 plus or minus the square root of now b squared, which is 7 squared, which is 49, minus 4 times a, which is 2, times c, which is 3, over 2 times a is 2, so here we shall have 4. So this equals to minus 7 plus or minus the square root of 49 minus 4 times 2, 8, 8 times 3, that is 24, over 4. Now, this equals to minus 7 plus or minus 49 minus 24, we have 25 over 4. The square root of 25 is plus or minus 5. So this equals to minus 7 plus or minus 5 all over 4. all over 4. We wrap here. Now from there, we are saying that m equals to minus 7 over 4 plus or minus okay, we have two values of m here. So we shall say M1 will be equal to, we now take -7 minus 5. -7 minus 5. We have negative. Okay, we shall say that M1 equals to -7 minus 5 all over 4. That is M1. And M2 will be equal to -7 plus 5 all over 4. So this equals to -12 all over 4, which equals -3. And this one equals to -7 plus 5. We have -2 all over 4, which equals negative a half. Therefore, these are two values of M. Now, when you have M1 and M2, the complementary function of this part of the equation will be Q will be equal to A. We know it's given by A exponent M1x plus B exponent M2x. So our Q now will be equal to, now we have M1 and M2. So it will be equal to our M1, which is -3. So it will be A exponent -3x. Now it's t. The variable in this equation is t. So it will be t. So this is now t. We replace the value of M1, which is -3, then plus B exponent minus a half t. We replace the value of M2. So this is now the complementary function. And remember, the chain resolution is given by complementary function plus particular integral. So once we have gotten the complementary function, we move on now to get the particular integral. Let me note this here. Qt equals to A exponent minus 3t plus B exponent minus a half t. Now we move on to get the particular integral. Now, when we have f of t equal to sine t, our assumed pi will be Q will be equal to, this now assumed pi will be equal to C cos t plus d sine d. So this will be our assumed pi. Therefore, we differentiate this equation. Dq dt will be equal to, when you differentiate sine, you get cos, sine t, you get cos a. When you differentiate cos t, you get negative sine t. So here we have minus c sine t. When you differentiate sine t, you get cos t. So we have plus d cos t. Now we differentiate this equation again. So we get d2q dt squared equals to, now when you differentiate sine t, you get cos t, but still you have this negative, so it will be minus c cos t. Then when you differentiate cos t, you get negative d sine d. Now once we have this, we come and substitute in this equation. Now we have this, which is this one, and then we have this, which is this one, and then of course q now is this one. So we substitute in this equation and equate to sine t, so that we can get the value of c and d. Okay, so we can substitute this. So we have 2. We write these 2, and then this one is minus c cos t minus d sin d, close the bracket. Then we have plus. Remember, we have 7 here, so it will be 7 into. We now replace this, which is this one, minus 7 minus c sin t plus d cos d, and then plus. Now 3 into, now this one, c cos t plus d sin d, then this one equals to sin t. We wrap this. Now we open up the bracket. We start from here. So 2 times this, we shall have minus 2 minus 2c cos t minus 2d sin t, and then plus. We open the bracket here. 7 times this, we have here now minus 7c sin t, and then plus 7d cos d, then plus. We open up this, it will be 3c cos t, and then plus 3d sin d equals to sin t. Now, do we have like terms? Yes. We want to group those that have cos t, we put them together. We have this, we have that, and then we also have that. We put them together. So we shall have minus 2c, which is this one, plus 7d, which is this one, plus 3c, which is this one. And then, of course, we put out cos t. And then we have what? Plus, we have this, those that have sin t, minus 2d, which is this one, minus 7c, which is this one, plus 3d, which is this one, equals to sin t. Now, minus 2c plus 3c will remain with c. So here we have c plus 7d cos t, then plus. Here we have minus 2d plus 3d. We remain with the d. So we have d minus 7c. Here we have, this is sin. So here we have sin t equals sin t. Now here we equated the coefficients of sin t. So on this side, we don't have cos t. Therefore, this one will be equated to 0. So that you have 7 plus 7d, c plus 7d equals to 0. And on this side, we have sin t, we have sin t. So the coefficient of sin t on this side is 1. On this side is d minus 7c. So we have d minus 7c, this one equals to 1. So we solve the two equation to get the value of D and C. If I can make C the subject in the first equation, to be C equals to minus 7D. So that is the value of C. So when there is C in the second equation, I replace with minus 7D. Therefore, here I have D minus 7. Now I replace C, which is minus 7D equals to 1. So D now minus, and so here we multiply, so it will be positive. D plus 40, D plus 49D equals to 1. What does it mean? It means that 50D equals to 1. Therefore, D equals to 1 over 50. You divide it through by 50 to get the value of D. Now, after we have gotten the value of D, we can also get the value of C. Remember, we have said that C is given by from this equation minus 7D, and then we have the value of D. So C equals to minus 7 times 1 all over 50, which equals to minus 7 all over 50. So that is the value of C. So once we have the value of C and we have the value of D, therefore our particular integral, remember our particular integral was Q equals to C sine cos T plus D sine D. So we substitute the value of D and C. So our particular integral therefore will be Q equals to C is negative 7 over 50 cos T, then plus D is 1 over 50 sine T. So give me a wrap here. Now the general solution is given by equals to complementary function plus particular integral. Complementary function plus particular integral, which equals to complementary function is A exponent minus 3t plus B exponent minus a half t, then now plus the particular integral, which is now this is minus, it will be minus 7 over 50 cos t plus 1 over 50 sine t. Therefore, this one will be the general solution of the given equation. Thank you for watching and listening.